Okay, hi everybody. My name is Wilson Cheung. I'm sorry that I cannot present my proposal in person. That's why I make this video record for make you know that what I will do within these 3 or 4 years for my PhD thesis. And my PhD content is about uh, glacier geometry and mass balance change at Summit and Ayutthaya National Park in Nunavut in Canadian Arctic between 1959 until 2025. All depends on the data I will have. And actually, this is the picture from 2 weeks ago. This is called Turner Glacier, which set up a new mass balance measurement in this area. That's why I will show you later what I was doing for my PhD research. Okay, before we start everything, I will talk about my motivation. And I would like to draw your attention in this graph. You can see that all over the world, the glacier distribution, and the first largest glacier you can ice mass you can find in the Earth is for sure in Antarctica. Second in Greenland, and the third one actually is Canadian Arctic. You see that north and south. But however, and according to the World Glacier Monitoring Service, there's only few reference glacier. What does mean reference glacier? It means that there's more than 30 years mass balance record. And as you can see in here in Canadian Arctic, there's only one mass balance record is over 15, actually 30 more years. And only White Glacier, which is what Dr. Laura Thompson's monitoring. But however, you can see that still in whole Canadian Arctic, and there's about 40% in the south of Canadian Arctic, but there's none of the reference glacier we will have for monitor. And why this data is very important, and I'll show you why. According Dr. Hawk, and you can see that these are using the mass balance and or another model to project a different kind of scenario. How many ice mass will be lost, which will contribute to sea level rising. And you can see that in here, there's a lot of big uncertainty because we don't have that much geodetic and glaciological mass balance record to the model to run to predict future scenario. So there's a significant knowledge gap that we need to expand our knowledge in the southern Canadian Arctic because which is quite a lot of ice mass in all of the world. So that's why this is my motivation to expand the data knowledge as well as the monitoring spatial and temporal scale in order to understand more deeper about the future scenario of this Canadian Arctic changing. And let me introduce the study area for you first. This is Banffin Island, yes, in Canadian Arctic. And there's two national park I mainly focus on. B is a Summit and near Pontiac. And there's one glacier. You see this big giant glacier that previous there's some glacier monitors with different kind of institute did it already, and from this year, our ice lab at Queen University will take over this monitor service, and then we'll continue the mass balance monitor. Same as Penny Ice Cap in this giant massive glacier, and they have another monitor service already, but we're still missing a lot of data because of the pandemic and logistic challenge. We don't have data since 2018 until now. Okay, the first objective of my study, first of all, is to set up a new geodetic, sorry, correction. to set up a new glaciological mass balance monitor internal glacier inside the Ulatuk National Park to make sure that we have a sustainable monitor to capture the atmospheric signal. It means that how they melt in the long-term approach. And um, we just finished install six spatial stick on the Turner Glacier with only manpower. Because suppose we have a helicopter and twin otter to go to Penny Ice Cap, but however, logistic challenge, we cannot have this um, support. End up we using snowmobile and ski up all the way or on this glacier that no one monitored before. And we install six sticks that hopefully next year we return and see how they melt. And this is Dr. Laura Thompson's and she drill, and then this is me. I drew to carry a lot of gear on the top of the Turner Glacier, and how the our spatial stick work is we install 6 meter, actually 5 meter stick underground and 1 meter stick on the top of the ice. So when the ice melt and next year we return and we'll record how the elevation difference in order to um, interpret how many water they contribute to the sea level rising in the whole region. So this is the objective one as in process, and we're still making a progress for this. Second objective, we try to using eco equilibrium line attitude. We call it ELA. Using this kind of ELA method to fill up the gap of the mass balance record we have. And what is mean ELA, equilibrium line attitude, is mean that in between accumulation area and abrasion area. In the simple way to say is in the mass gain of the glacier and the mass loss of the glacier, in between this balance, we call it ELA. And if the glacier is getting healthier, getting more snow cover to gaining mass, and the ELA will decrease. And if they melt quite fast, the ELA will increase. So this is a good indicator to see the mass balance, how they change as well. So we're using this indicator or index to predict how they go for the future scenario and fill up the gap that we cannot go and collect data. Actually, this is a penny ice cap ELA. You can see that this is a down trend, and with this gradients, we can just fill up the gap. For instance, this is 2015. They don't go back to collect the data, but still using this projected line, and you can fill up the gap, which we don't know. So this is the second objective. The first objective is quite big chunk of work, but it's quite simple. And we're using historical air picture. It means geodetic satellite or historical picture, and plus the glaciological data. It's been on I we collected to measure or to identify all the glacier along this path. Geometry changing, attitude, or how the area extent change in order to predict the future that they may have potential nature hazard. And plus the knowledge from social data from Parkinson is being needed by the community and Ponet in another community, and in order to provide more detail about the glaciological change in this area for the park visitor, from local family, and from people that they care about this land. So this is the whole objective, and I'll go through the methodology, how the method work, and I'll make it faster a little bit. And this whole chart that my backbone of my PhD proposal. First of all, we're using historical air picture, and then do some photogrammetry, and then create a DEM that will this is become a historical DEM to compare with nowadays. What does it mean? DEM is a digital elevation model, and with this DEM, if compared with nowadays DEM, you can see the elevation change with this, and you can identify some geohazard. And moreover, that how we get the ELA data is from the satellite images each year, and then we identify the elevation of the altitude of the this equilibrium line, and then with this we estimate uh, the mass balance. For sure, we add on our fieldwork as a mass balance so that we can compare everything with elevation change and error extent to identify the geohazard. For sure, local inert glaciological knowledge will be input as well, so that as well as on-site when we go to ski or summertime using helicopter visiting, we can give some more uh, depth detail for the visitor as well as the park Canada and local community as well. Okay, some free method uh, on uh, on ice data. It's been using the spatial stick. We install each year. We need to return, measure the elevation change of each stick, and as well as install the stick along the major glacier we indicate we should monitor. And for penny ice cap, hopefully next year we have a helicopter to retrieve some stick. If not, we continue our Turner Glacier to replace penny ice cap monitor. And for the grammetry, and this actually in Simit, it's mean Pilot Island, and this is the glacier that I have to monitor. And then this is the historical air picture from National Air Picture Library. And I just asked them to send me some sample, and I want photogrammetry to make this DEM already. So it's quite work very well. And last pass using the ELA to estimate the mass balance gap and to fill up the gap of this year that they missing because of pandemic or logistical challenge. And since the ELA, the equation is being calculated ELA, is being per each year summarized with mass balance gradient and then plus each year gradients. So if you play around and become second equation, the mass balance of those year or of specific year is equal to calculate ELA plus the real ELA minus the ELA, and then multiplies with the mass balance gradient. So after this, we can estimate the fill up the gap of the mass balance. And finally, some geohazard nearby, for example, Plankinton, this is the water resources they have, and moreover that there's some glacier dam like this. They may just flooding or whatever. So we need to study this area too. And finally, and during this process, although we are cooperate with Park Canada, and I still would like have a passion that to train up the local Inuit people to take over this glacier monitoring service for contribute to using their perspective, the local perspective, to contribute to let the people know that over to know that how the ice and glaciological knowledge from Banff Island to all over the world. So this is my presentation, and I'm sorry that there's no Q&A, but I'm welcome that if you have any questions, just send me email, and I'll do my best to answer you. And thank you very much. Hope it's not too complicated for you. Okay, have a good day. Bye-bye.